Comment tu vas? Non, toi, c'est bon, je vais te faire voir. Ouais, c'est une casquette de pique-nique. Ben non, je suis pas chaud. Regarde, pas de chaud. Ben ouais. Déjà, t'es pas en vacances. Il est devenu tout blanc lui aussi. Comment ça va? Ah bah si tu veux, hein. C'est quoi? Non, je dis on va couper le micro, je suis désolé. Tu viens juste d'arriver? Tu redécolles ce soir cette nuit, je sais plus exactement. D'accord, mais c'est bien. Sauf que j'y étais lundi dernier, je suis rentré entre deux. Mais bon, c'est la vie, c'est le souci. C'est quoi ce smile? Non, je parle français. Tu vas me tenir le badge? Oui, non. Je vais pas te le dire. On parle en français, les gars. C'est pour draguer les petites françaises qui va dans le parc. Non, mais il y a une même. Ça marche pas, je te rassure. Si, ça marche, c'est toi qui pas de eux, ça marchera pas. Yes, well, I'm checking with you here because I reformatted, I sent something unprepared and then I reformatted it just before. That's a 64. Okay. All right, it's okay. This is KP. It's new to the IETF. We haven't seen it. Come on, I missed one. When did you fly? 10 minutes ago. When are you leaving? Tomorrow at 6. Oh, 2 whole days? Or 6 in the morning? Yeah. So this is JP, we don't really see him at the Still got this. Yeah, I was just saying that it's going in the Ah, yeah, sorry. Is he? Yes. Oh, that guy is. He's in 6 years.
Okay, hello. Welcome everyone. This is the past competition element working group session. We should have 2 blue sheets circulating in the room, so please make sure that you sign them. It helps us to have the correct room dimensioning. For those who weren't at IDR yesterday, for instance, the room was too small, so please make sure you do it. Dan will be our note taker today. Does anyone can be? Drav is going to look at Jabber. Thanks. And usual reminder, before requesting slots, make sure that you actually need face-to-face time. Make sure that you use the mailing list between the meeting to progress your work, to gather some feedback from people working on the working group or on PC stuff, and then trigger slots when necessary. Okay, the not well related to IPR in the IETF, anything you say, right, and so on. You should be familiar with them, but if not, read them carefully, please. We have a change, or a few changes within the routing area, so you may be aware that CCamp has a new scope focusing on non-PSC technologies, and that the TE architecture on the SVPT have moved to the new TE's working group. So we will be interacting probably as much with TEs as we used to be interacted with CCamp. We will witness Normally, at the end of the day, a change of AD concerning the PC working group. Adrian is finishing his period of AD, so thank you, Adrian. PC owes you very much. And Deborah is taking over and will be our new AD for the PC working group. Welcome, Deborah. I think Deborah used to chair T-Camp for long, so I think many of you are familiar with her, and she already knows much about PC, so welcome. Okay, agenda. Anyone want to bash it? Okay, so you'll probably notice that we have an open mic session in the second part of our agenda. It will be a moment for you to discuss, comment, share your views on what could be the next steps for PC. The milestones, we have much read there, but the good news is that for many of them we have work in progress. For several of them it's just a matter of polishing and setting the document to SGSG. The work is pretty mature for several of them. So we will have on our side involving probably a few other shepherds to make sure that we don't leave too many documents behind, and we'll try to make some new space for possible new work or close the working group if no new work is coming for the PC. Okay, in details, we have 3 new RCs which got published since the last IETF meeting. The MIB of PSEP finally. Thank you to all people involved in this. It's been a long way before publishing that MIB, so it was a huge work. Thank you everyone to achieving this. Yes, and we have probably already, which is a good news, some people working on what could be next after SNMP MIBs. We have the requirement for routing and web assignment in WNM networks, which is also preparing the place for the extension within PSEP, which is a document that we already have in the working group. On the vendor constraints again, which is the fix for the code point clash with some stateful early drafts. So this new 7150 bis is just, or almost just, fixing this clash within the INR registry. We have not less than 5 documents which passed working group last call. Most of them are ready. One maybe have some pending comments. I think Drew raised some. I don't know if you got some direct answer offline. So we'll have on our side involved Shepherd to move forward with the documents which are ready, and we'll hope that the last one will be fixed and comment addressed in a very near future. We have some expired documents, some of them being related to documents that we have already in the pipe. The GMPLS extensions within PSEP are almost ready, so as soon as they move to the IESG and move forward, we'll probably be able to last call the interlayer extensions on the RWA extensions. And we have 4 documents in less clear state, so if you're involved on them, maybe you want to come at the mic and provide some information. The famous inter-area, inter-domain applicability, discovery MIB, errors on the GMPLS remote initiated LSPs. Any comment on those, or comments are welcome on the list offline also. We have a new working group document since the last meeting, which is the IRO fix or update, not fully a fix, but clarification and about the ordering of the IRO, on the discussion that we have had on the list over the past few months, following up the survey that Trev led over the implementations. So this is a simple draft which could progress pretty fast, but which make clear some ideas that were understood almost the same in multiple implementations. Some working group drafts which aren't on the agenda for today. We have the hierarchical PCE extensions. We saw some recent update in January, if I remember correctly. There is a proposal for more contribution sent to the list. So this one seems to be still living with maybe a few little extensions to include, but progressing pretty well, on maybe ready for an end within a few months or weeks. I don't know exactly. The domain sequence, which was presented in Honolulu, maybe Drew, you want to comment about that one quickly?
Hi, Drew from Huawei. So regarding domain sequence, I think after the IRO update, we have no other pending data. I think we are ready to go. But the two documents are interrelated and have to go together. I should cover the second point as well, which is...
Yes, please.
Which is with respect to service aware. So based on the feedback, we merged the bandwidth utilization separate document into the working group document. We did another update, which was basically more editorial, aligning the whole document, and also checking on with the ISG review that the OSPF document received. So based on any open items, we have none, and both the documents is ready, at least from the author's point of view.
Okay, thank you. Then we have the stateful GMPLS draft, which was a bit tackled during previous meeting. Xiang, you want to comment about that one, please?
Xian from Huawei speaking. Just answer your question directly. Yes, we think it's useful, but we have a couple of pending issues, and we're going to discuss among authors during this week. And I plan to have update before next IETF, and then it's probably not ready for last call afterwards.
Okay.
That's the plan. Yeah.
Work in progress then. Thank you. We also have the PSAP extension. We're using TLS, the PSAP S. Oscar, maybe you want to comment on that one?
Just a quick comment that the last updates were just cosmetic. I mean, just things. So the procedure itself is ready to go for the last call. The only pending issue was the naming that there were a little bit of fun. You see that the naming the PCPS, but there were no proposals in the list, and we tried to come up with a better naming, but this is what we have so far. So unless someone finds a very fancy new name, we'll keep on with PCPS so far.
So could you just repeat actually the last two sentences?
That unless someone comes with a new name, we'll continue with the PCS so far in the document. Unless someone, because there were no proposals for new names.
So did you, I can't remember to be honest, did you ping the list actually to find, because it's a little bit ambiguous, you know, that name, obviously. You agree, right?
Yeah, but
so maybe we can open a contest or whatever, I don't know, something like that, to find a good name. Okay, let me drop an email to the list because,
yeah, sure.
Yeah, it's, you see what I mean, you know, it could be thought as something different, like HTTPS or, you know, that kind of protocol. And that's not what it is, so.
Yeah, but so this, I think, if this can go parallel to the last call, I mean, just if we can move, because it's just the naming, right?
Yeah, no, absolutely.
Okay.
That's okay, it's a minor issue. Thank you.
That's to sure that it's a non-blocking issue. Okay.
No, it's not a blocking issue, no worries.
Okay, perfect.
Okay, I think we're done with the working group status. So we'll leave the floor to the first presentation.
Good afternoon. I'm going to talk about PCAP extensions for segment routing. Next slide. So first recap, segment routing technology where we use IGP to distribute labels of information reachability to the nodes. Gives us ability to form a tunnel from ingress to egress without any signaling protocols. So progressing in Spring working group, very, very successful technology. Next slide. So PC models. PC could be both external to the network as well as running on one of the networking nodes and hence work in existing deployments as is. Next slide. So both PCC and PC instantiated are supported. So PCC could request a segment routed path from a PC, or PC could provision a path driven by, for example, application within controller. Next slide. So what we define is new segment routing ability TLV. It will be an exchange during open, so both PC and PCC agree on support for segment routing. Very important, it also has MSD, which gives ability PCC to expose number of seats supported. So it's really data plane capabilities, and when PC performs computation, it can use depth of the stack as one of the constraints. Next slide, please. So we define seat, which is segment identifier, and now which could be IPv4 not, IPv6 not, IPv4 adjacency, IPv6 adjacency, and a number. So very important here, we can provide imperative seat, so label stack identified by labels, or we can provide number of IP addresses and hence give the node ability to use local tag or any local machinery to translate IP address of node or adjacency into particular label. So very flexible. Next slide. So a raw object has been decided and has exactly same semantics as ERO. And it's really out of scope how you can use it. Next slide, please. In next presentation, we'll talk about path setup type and how it can be used in segment routing. So we've been discussing for a long time. There are 4 interoperating implementations. It's actually working. We've also tested it during the NTC event in Berlin 2 months ago, and proving that there are 4 interworking implementations. We would like to proceed towards working group last talk. Questions?
Robin from Huawei. I wonder to the previous slides, I have some question. Okay. Again. Okay. Next. Okay. So here I think the master segment depth. This the number of the SID is notified from the PCC to PCE. What's the issue to prevent?
Imagine you can only support label depth of 4 labels. So if PC will impose path which has to have 6 labels,
you won't be able to push this number of labels at ingress, hence you shouldn't really accept this path. That's how we use it. So PCC communicates back to PC. This is how many labels I can support in the stack. And then when PC computes a path, it should use it as a constraint imposed to the data.
Okay, I think according to my understanding, this is related with MTU or not?
No, it's not. It's related with NPU capabilities to push particular number of labels. And it varies from 3 to 16 depending on vendor.
Okay, you just means that the SR path, that means the ingress node can, how many the SID can be pushed?
At ingress, correct.
Okay.
And again, it goes back to loose versus strict, where in strict you need to impose number of labels, which is really number of adjacent segments, while in loose you could pretty much deal with one, which is your egress.
Okay.
We have a job that we discuss service segment support, and in the mailing list we propose to merge with this job. We think it is a small extension, and we can use in the service segment as you propose using node segment, adjacent segment. Also, for service segment, they have some use case proposed in Spring working group. We like to get answer from all of this draft. But we haven't get from the mailing list, so we want to raise again.
So we discussed it among authors, and while this draft described very generic capabilities, the service chaining is very particular capabilities, so I think current way of thinking is not to merge.
I agree with that. We don't want to push a solution specific for a single use case there.
John Hardwick. So I wonder why the max segment depth isn't a constraint given on the query rather than something that you give in the open.
It's optional. It's up to PCC whether to advertise it or not. If there are particular constraints and advertised, it should be taken into consideration when computing and then pass a number of seeds in the label stack.
Yeah, my question was really why is that not given per query rather than...
It doesn't change really.
Well, so one of the ways in which PCE can be used is if the tool issuing the query is not the node, but is maybe a management station or some offline tool for doing provisioning planning, in which case it may be issuing queries on behalf of many different nodes in the network. So are we saying that this would never be used in that kind of scenario?
The idea here that it's communicated only once during open, and then it's well known, and you expose it to either PC computation or any other entity.
Yeah. So I'm not sure if I'm making myself very clear. If the device that is issuing the query is not the edge router, but is some third-party device, some management station or offline provisioning tool, then it may be issuing a path computation query on behalf of many different edge routers, all of which may have different constraints in terms of stack depth. So I wondered if that scenario was ever applicable to segment routing, or if that's just out of scope.
It's a valid comment. We'll discuss it across authors. The idea here that it's only relevant to the ingress or ingress node, because this is the node which pushes all the label stack. For the rest of the transport path, it's absolutely relevant. They don't look at all the labels, only at top level.
All right. Well, talk on.
We'll discuss. Thank you.
First, let me do my Java duties. Let me go. Then I have a question myself. So from Java, Cyril, shouldn't this document request early allocation of code points since you have early implementation?
It should. Very well.
And are you going to do it?
Yeah.
Please proceed.
Throw from Huawei. There was one query on the mailing list, I think from Joydeep, and Daniel forwarded it. This was also related to MSD, where though we know the ingress MSD, we may not know the MSD that is supported by the rest of the path. So I think it's important that we somehow capture that. I don't have a solution, and what's the way we should capture that? Just a comment.
To begin with, it's up to Ingress to push complete label stack. The rest of the nodes in the transport path doesn't look into label stacks, help only adopt 1 or 2 labels max. So it's not really relevant. Secondly, I think we are working on extensions to provide additional capabilities to IGPs to advertise maximum label. I think Shri is going to, we are going to talk about it.
Okay.
During the spring session.
Chris Bowers, Juniper Networks. Does the current document have an implementation section? Because you mentioned as sort of motivation for working group last call, the 3 to 4 interoperable implementations.
Not yet. We are going to put together an implementation report showing interoperable OSS and potentially some
Okay, so a
other-
separate implementation
Yes,
report?
it's going to be a separate report presented as a draft.
Okay, no further question? Then we'll move to your second ID.
So this idea is about setup type TLV business slide. So if we look at what's existing today, we can only provision SVPT based LSPs. So what we proposed here is to have generic TLV to facilitate such facilities, so we can indicate type of tunnel we request. Next slide, please. So PSP field indicate methods to use. So in order to keep it backwards compatible, we assigned value of 0, as well as in absence of this TLV, we assume it's RCPT. PST of 1 indicates it's segment routing. It could be case in other RPO, SRPO. So been around since 88, implemented as part of segment routing story. We would like to ask for working group last call. It will be included in interoperability report we're going to write. Question?
Okay,
Thank you.
thank you. We'll move to the next slot. You want to comment?
So, quick question about these 2 drafts. Anybody that would oppose to do a working blast call? Pardon me? About the segment routing? Both, I mean.
So this is Adrian as an individual. I thought that John's point that he made at the mic was misunderstood by Jeff and needs to be handled. And it, you could do that handling in last call, but it will change the bits on the wire. And given that there are implementations, maybe that means it's not ready.
That's fair. Any other comment? No? All right. Thank you. There's one.
Dhruv from Huawei. There are a couple of editorial notes still in the document. It still says a few things which are TBD. So I think just a quick revision. Otherwise, we all support it. It's just a little extra push to polish the document off.
Yeah. I also noticed, a few things like you've got individual draft in the normative section, but it's probably because you didn't refresh it.
Yeah, we'll refresh it.
Yeah, just a few things like that. But.
And don't forget about the early allocation if you feel like it.
One more, Cyril on Jabber. Based on the comments, it seems early to consider LC.
Yes, please.
Good afternoon.
Please, could you try to stay within the pink square? There is a camera right in front of you. If you don't mind. Thank you.
I'm Jianji. Our draft is about the PCEP extensions for SFC in SR networks. Okay, next please. What we want to do is allow a PC to compute and instantiate service function passes in Spring Network and support different types of service function pass by PCE. Then specify extensions to both stateless PCE model and the stateful PCE model. Next, please. Okay, this figure shows the whole architecture for how PCE is used to compute service function paths in Spring networks. Usually PCC is co-located with SFC classifier, and then PCE is connected to the SFC classifier. For example, in this figure, if we have a service function chain, for example, SF1 to SF3, this service function chain can be expressed as for FF1 to SF1, and then to FF to SF3. And what want we to do in this draft is how to represent this service function path user SIDs. For example, here the SFF can it's represent can be user node SIDs, and the service function can be represented as the service function SIDs. So this is the requirement, and what we done is based on this architecture. Okay. In order to support the PC to compute the service function path, here the extension to the PCEP messages for the PC request message, and there's no change to the message format, but we need to require to path setup type TLV. This TLV has already defined in the draft I listed issue here, and then this RP object is in order for PCC to request a particular type of SFP. Actually, we defined 4 types of the SFP. For the details, you can read our draft. And then for the response message, we defined the format to carrying an SFP format from PCE to PCC. In this draft, we had updated to support the state for PCE, so we added the PC update message and also the response message. That's the difference from the previous version. Yes, please. Okay, here shows the details of the object formats. The open object, we proposed the SRSFC PC capability TLV. And this one is to use the this TLV is optional. It is used to negotiate the SRSFC capacity on the PCEP session. And then the RP object. This one is used to carry to tell the PCE what kind of SFP is requested by the PCC. For example, here we list 4 types of SFP. It could be a SFP or compact SFP or SR specific SFP. All the definition for this kinds of SFP you can look at the draft. Okay, next please. This one is we defined the in IRO we use defined a new sub-object type. It is for the service function ID, and then the SRSER object. Here this one is used. For example, it is we defined some new field like the NSI type. It's node segment or service function segment. Okay, next please. Okay, this draft we had first presented on Toronto meeting, and after that meeting we have received many comments. And for example, it should to support the stateful PC model, and we have already updated the draft to be consistent with the latest service function architecture. So that's all question.
Any comment from the floor? While Jeff is coming, I'll just add a comment. I think that in the draft you start by referring to an individual document in SFC, which is your associated architecture. So doesn't make sense to add up a PSAP extension if you refer to an individual architecture. Besides, I think that SFC has just adopted a new working group document for solutions. So here again, it seems premature to promote a solution specific to SFC while the work is going on over there. So maybe you need to lower down a bit your speed within the PC working group for that proposal and focus more on the SFC specific documents first. Jeff?
It's very much related to comment, really applicability of it. Pretty much no VNFs understand what label stack is. I did a prototype on it, removing MPLS header, passing pointer to it create huge amount of state and really complicated. So it would be really good if you could go to SFC, talk to them, and see whether you can really come with applicability for.
Any other feedback from the room? Thank you.
Here we go. Dhruv for Yang model for PSAP. I guess everybody's favorite topic. Please. This is audible, right? Okay. So this is the Yang model for PSAP. It has all the configuration, operational, as well as the notification for management of PSAP. We presented this last time in the last IETF, where we tried to capture most of the things in our base RFC 5440. With this update, we tried to add PC information, which is either discovered or statically configured. This would be the domains information, path computation scope information, and the capability information. Next slide. I think I'll continue anyway. So in the basic design of the Yang, we have the PSAP config, and then we have a PSAP state. The arrangement is with respect to entities, peers, and sessions. So where the entities and peers are can be configured and also present in the state, and sessions are only operational, and that's why we see them in the state. We have used groupings wherever possible, so that the information that is shared between peers and session and information that is shared between config and state can be easily used. So this is where we are. And the next slide, please, where we show the update that we have done in this version, where we are now having path computation scope, information about which PC domain and neighboring domain, and all the capabilities. Next slide. So this week we also had an offline discussion with a bunch of people regarding what's the next step that we can take with respect to PCEP Yang. The first thing that we sort of concluded was, right now in the document we are not using features, so we'll go through the document again and see where all features can be used, and follow a specific principle that anything that is must in the base draft will be there, and anything which is optional or any extension after 5440 can be used as a feature. What should be the next step? As we know, after PCEP, we tried to do the working group has moved to GMPLS, interdomain, and bunch of other extensions, but we thought that this moving directly to stateful PCE with respect to Yang is the right approach, because that's where the work is with respect to management and reuse right now. As I mentioned earlier, that currently in the document we have an entity list, which is some concept borrowed from the PCEP MIP. So I've been trying to get feedback whether it is useful to keep it, or when we are trying to do this in Yang, try to remove the concept of multiple local entities in the PCEP. So initial opinion that I have got from people is this can be removed, and anyway you may have seen other discussion happening in consolidated open config where concept of logical routers or other things are going on. So I think from the protocol point of view, should we worry about multiple entities? That's the question, and I'm open to feedback, and please provide your feedback for that. And thank you for everyone, and we need more feedback with respect to PCEP Yang to move that work forward.
Yeah, I just wanted to encourage you to help, because I think this is a very important piece of work. And did you find out actually some mini ecosystem to help you out?
Yes.
Okay. Done. Okay, here we go.
The only one comment, I would really like OpenConfig folks to comment, provide early comments so we can proceed with this work in agreement.
Hi, Daniel King. So it's really good that you're having this discussion around sort of the applicability of Yang for managing networks that contain PCE. You're having those offline discussions, great, but this is a consensus-driven organization, so try to have the discussion on the list, at least raise the issues, give people the opportunity to attend some of these offline discussions. Not everyone may be party to that. Perhaps you can report the findings as well at the end, rather than just updating the document. I do think the document may be slightly premature in that, have we really had enough discussion to see if we're using networks that contain PCE, what is it that we actually want to manage? Not just the specific elements of the PCE architecture, but how is the PCE being used? And there could be sort of impact on other management protocols as well. So we're seeing PC being used in various open source projects. I think it's worth sort of investigating how it's being used there and seeing if that potentially impacts some of the core protocol work that we're doing here, and things like Yang as well, but potentially other mechanisms.
All the criticism taken. The thing that we thought was that this is sort of the base, the least minimum thing that we need with respect to any PCEP, just the protocol part. The next step, as you have clearly said, is that, and I think the use that we are clearly seeing, whether it is in open source or otherwise, is right now in stateful. So that's why we want to quickly move to that direction by adding stateful and analyzing how people are using the stateful PC applicability. The feedback that I'm getting from the room is basically, let's move to stateful so that they can contribute in that direction. So hopefully I'll be able to add what you're saying once we go to stateful. Yeah. Where we also not just worry about the protocol, but how do we use, how are we managing?
Yeah.
As well.
Cool. And just sort of one final thought then. Maybe you can pull the model out and upload it to one of the GitHub repositories as well.
Done.
Done. Okay, cool.
So this is just the next step. So I'll be starting working on the stateful PC with a bunch of authors, and I will send out the list. Anybody who is interested, please free to join in the discussion. Some of the points that I specifically wanted to add here was that when we move to stateful PC, we'll definitely have the LSPDB. We would of course like to augment the LSPDB, which is done either in TE, or there is also a discussion going on generic LSP in Ts. So based on whatever conclusion that we make, the PCEP should not have any way. PCEP model should only augment PCE related parameters of the LSP, which may be BLSP ID, symbolic path name, or anything which are PCEP protocol related, and we don't have to model. We have to rely on the model on something as a base. So we will most probably be using the TE LSP model, which can support both RSPP TE as well as SRTE. So that is with respect to the LSPDB. Secondly, when we move to PC initiation, stateful PC initiation, so how we initiate the LSPs at the PCC, we have to augment the same model and use it at the stateful PC by adding few extra parameters. So this is just something that I wanted to be upfront while we are going to start this work. This is the decision that we collectively made during the offline discussion here. And I will send out the meeting notes that happened, and will bring everybody in the working group up to date of what's happening here. Reviews and collaborations are open, and we think that we can get much more feedback and better collaboration if working group is in control of it. So adoption, please.
I have just one comment here. I mean, as you are trying to cover all the PC protocol in the document, I mean, the only problem I see so far is the risk that there is a never-ending draft. So what I would propose is, like, if you can say, okay, instead of going to the stateful, for example, okay, let's take a stop in all the very, very stable documents, do a first young model which can be augmented, and then let other next document augment it, so then you have a very stable document, a good base document, and then extend it, because let's say stateful is even growing, keeping, and what I don't want is that it takes forever.
This was indeed a point that we discussed. That how should we handle the stateful extension. So far our initial gut feeling is saying that stateful PC in itself is big, but we can rely on a lot of things from the generic models. The PCEP specific parameters that we will have would be sort of limited in our initial judgment. So our aim was we'll start writing in the same document, but moment we realize that it is becoming unmanageable, definitely breaking is the right choice. So we'll start with identifying the leaves and identifying the design, and if the feedback that we get that it needs to be separated, we are completely open to that.
Yeah, I just wanted to comment on the adoption as a working document. You know, I think it's a little bit premature because we haven't, personally, you know, I told you, you know, I think this is great work, but it's a big chunk of work as well. So before adopting, you know, the usual comment would be to start generating a little bit more traffic and see if we have enough traction in the working group. Make sense? Or okay, super, thanks.
Especially we have almost 2 comments related to scoping the work properly, which is a huge work by itself. So maybe try to trigger discussion involving Oscar down on the working group on this to make sure that all you do can be then properly filled in and progressed efficiently, maybe in few documents if necessary, several documents. Thank you. And I think you're next again. Cyril, I guess.
There is one comment of Jabber. I don't know if it's for this, in draft the PCS stateful PC auto bandwidth adjustable interval is expressed in second or in minutes. I don't know if it's for this one. I think it's maybe for the next one.
I think I'll...
This is your next presentation?
This is the next presentation.
Okay, then the comment is for the next presentation, sorry.
It's from the future.
So this is the PCF extension for supporting auto bandwidth adjustment. Next slide. So as we know, the auto bandwidth adjustment is a feature that we have where the bandwidth can be changed based on the measured traffic load. It's something which is usually supported by most vendors already. Now, when we are using when we are using stateful PCE and we are delegating control of the LSP, what impact does it have on the auto bandwidth feature, and what are the extensions that are needed? That's what we have tried to cover in this extension. And next slide, please. So basically, we last presented this document when it was a 0.2 version. We got comments from Ravi to enhance the document, and he's also a co-author now. And we also got comments during this meeting, and we will handle them as well. So basically, in this update, we have clarified that there are actually two clear approaches to do this. And the document clearly mentions that. The two approaches are whether PCC calculates what's the bandwidth adjustment that needs to be made and just notifies that to the PCE, and in another case, PCC notifies the bandwidth samples and the real-time bandwidth that is being used and let PCE adjust the bandwidth. So these are the two modes for auto bandwidth feature. We updated the TLV. We added support for PC initiated LSP as well, and other updates in security, manageability, and INA consideration. Next slide. So the two approaches, here is a little bit more description of the two approaches, where PCE is deciding the final bandwidth that needs to be adjusted. So of course we need to transfer and report the bandwidth samples as it's collected on the PCC. We also need to provide some configurable knobs like thresholds, min and max bandwidth, etc. to PCE to do this calculation properly. And the support should be there for both PCC initiated as well as PCE initiated. In case PCC is deciding the adjusted bandwidth and it is a PCC initiated LSP, we don't need any extension, that is already supported. We are just reporting that please change the bandwidth. But in case of PCE initiated LSP, and even though PCC is deciding what's the adjusted bandwidth, you have to pass information about thresholds and what's the requirement to the PCC so that it can make the calculations correctly. So that's why for both the modes we have need for some extensions. So this is the TLV that we have. It's an auto bandwidth attribute TLV. It can be carried in the report message as well as initiate message. We have flags and thresholds, sample interval, etc. In case PCC is only reporting the final calculated bandwidth, you don't need the TLV, but for the other cases of PCE initiated LSP or PCE deciding the final bandwidth, we have the presence of need of this optional TLV in PSEP message. Next slide. With respect to reporting of bandwidth, because we will be reporting the bandwidth sample and the real-time traffic measured value, so we propose defining a new bandwidth object type for that. But when it is the calculated bandwidth that needs to be adjusted, we can use the existing bandwidth type 1 for that, because this is just the requested bandwidth, but when we are providing samples, that is in a new bandwidth object type. So auto bandwidth is a feature that's been there in most of MPLS-TE, and when we are moving to stateful PCE, we would like to continue to use this feature in a seamless way. All the configurations and knobs that are already there in our devices, we would like to use them as much as we can. We welcome more reviews. In fact, we had a discussion with Rakesh from Cisco, and there are a bunch of suggestions that he has, which we have worked out, and we will update in the next. Yes. And like every presentation, is it a good place for working with Badawi?
So, any comment, any question, except mine? On Jabber, okay.
There are a couple of questions. One from Cyril, that the document has values for the different object types. Shouldn't values be removed from the document? Code points. That, yeah, that if they have values now in the document, that if
Oh yeah,
they...
I thought I removed them, but I'll have a look at them.
Okay. Okay.
Next one.
Next one. There is. They ask about a specific. A specific parameter. If the sample interval, if it's in seconds, in minutes, I think it's missing the time unit.
I think in seconds, and anyway, I think the TLV format most probably will change. We have got feedback from people that we may have to break that into multiple sub-TLVs, because not all parameters may be needed. So while I'm going to work on the new encoding, I'll take that comment as well, whether it should be in seconds or whether we have enough space for it. Right now it's in seconds and it's 8 bits, so we have to check whether that's enough or is there a need for more space. I'll take that into consideration.
Okay, a couple of more comments here. Has an option to specify absolute values as thresholds been considered? Could be useful for very high bandwidth LSPs.
Yes, that's the comment I got from Rakesh as well, and yes, in the next update that will be considered.
Okay, and finally from Cyril, I see knob for the auto bandwidth parameter. Isn't this management parameters?
Management parameters?
Yeah, for the knob for the auto bandwidth parameters.
I'll reply to Cyril offline.
Okay, perfect.
On that question, I'm not yet sure.
There's another one on the back, I think.
Yes, this is Dina Vinay. I have a question about scaling implications of reporting the sampling from the PCC. Have you?
Yes.
Can you perhaps address it in the draft specifically, because?
Yes, that's a very good comment. We tried to do via adding a report threshold, but exactly how that report threshold works and what impact will that have, I think I can add a separate consideration for that. I agree.
Yes, because I have like very heavy concerns about that,
okay,
especially at scale. So it works for a small scale, but it will not work for a large scale.
So I just have, one comment on my side. I love so much auto bandwidth that I actually designed it, years ago. I'm just super worried about the dynamics, quite frankly. So what I mean is this, specifying the protocol extension is one thing, and I think this is the right thing to do. We can debate about the thresholding and that kind of stuff. But when you think about the dynamics, when you have potentially, thousands of LSPs, and actually you even mentioned, the ability to some trending analysis on the PC, which you could do with a, time series, whatever you want to anticipate actually, this kind of stuff. So on paper, it looks pretty, I was about to say sexy, it's probably not the right term, but, at least appealing. But I'm just a bit worried, especially if, if you may at some point have multiple stateful PCs, you're trying to adjust with different algorithms, you may come up with something really hard to control, especially at scale. And we had that debate with Andrea, who is actually talking right now, but 10 years ago about leaking stuff across multiple areas. Again, on paper, it was fine, but when you look at the dynamics of the system, at large scale. I don't know if you looked at it, and that's not something we do well at the IETF, quite frankly. Usually we, not always, but sometimes, we tend to specify protocols, and then we deploy, and then when this is actually deployed, you look at it and you look at the dynamics, and you think that, well, it doesn't scale very well. I don't know if you, and again, this is a coach your hat off, just as a contributor. Did you have a look a little bit at what would happen if you had, for example, thousands of LSPs and you were trying to adjust with a granularity of seconds and, using time series, for example, or?
Of course, the feedback that I get from the solution department and other places that I can ask these questions from, they are saying that it's useful, but enabling auto bandwidth feature on every LSP that you have in the network is of course something that we would never do and we don't even want. But we would like, at least for some LSPs where it's important. So of course you have stable network, and as you said, enabling this feature on all LSPs, something that we are not even aiming for. It's for some LSPs which are very critical. It's for LSPs that are for our premier customers only. So among that, I'm trying to address this, not for all LSPs.
Right.
But I agree with what you
said. But in that case, if you do it just for some LSPs, it may defeat the whole purpose of doing auto bandwidth, because the other ones are going to be static and they can't adjust. The idea of auto bandwidth is precisely to have all of them doing the job. And I'm just saying that compared to the auto bandwidth activated on each LSR individually, potentially playing with preemption and these sort of things, that's probably okay. I'm just.
The good thing is that we are trying to do it on a stateful PCE environment, and there PCE, if things are delegated to the PCE and PCE is in control of it, he isn't still in control of it. So if he can realize that, oh, I'm going to create a lot of churn and I'm going to create a lot of issues in the network because what I'm doing, he can immediately stop, which was different from when we were trying to deploy this in a distributed environment and each PCC deciding what's the bandwidth to be adjusted and doing computation locally. So I have a feeling, and I have not tried this myself, but something I take your input and would figure it out. The idea there would be that the PCE is intelligent enough to not try to do something which is going to create.
And I'm sure your PC is very smart, no issue about that. I was not questioning that. I'm just saying, and we can take it offline and just have a good discussion about it. But typically, for that kind of a draft, I would suggest to have a section that talks a little bit about the scalability issues and things like that. And maybe at some point, if it's traction, the working group will decide, not me, but it might be good to have that, or think about experimental track, whatever.
Definitely.
Thank you.
So just to go back to this, the draft now allows two modes of operation, one in which the LSPs may be created by the PCE, but then are independent and they just resize themselves, and I think there's a lot of value in that mode of operation, because you may want to create them and then just leave them to themselves to resize. The other mode of operation where the LSPs have to report back the bandwidth and the PCE resizes them, that I find scary.
Good thing is we support both.
Last question for this draft, please.
Okay, so Chris Bowers, Juniper Networks. Contrary to perhaps popular belief, auto bandwidth is actually fairly widely deployed and operating in distributed mode. And so adding the capability to at least, and so in that distributed mode has some drawbacks, which is the whole point of PCE in general. So adding some capability to do something a little more intelligent with a global view could only, I believe, help that. Of course, you could take it to extremes and try to do things at extremely high rates that just won't scale. But in general, this is good functionality to that I believe used intelligently can only help.
Yeah, this is where I fundamentally disagree with the can only help. There are pros and cons, as you said. So we just need to evaluate the pros and cons, because I can give you some very concrete example where you can actually kill the whole system. if you go too far. And I'm not saying this is a bad thing at all. I'm just saying it's just to just evaluate what it means to do it that way. That's it. Not being against it, but we can sit down if you will, and I can show you some examples, especially if you have multiple PCs with different time series, for example. Yeah, it's great fun, right? Okay. Thank you. All right, next. Okay, so let's do that. Let me start a thread, just on the list, and we'll see if we have a consensus. Thank you.
Thank you. Next presenter is Homian.
Okay, thank you. This is Hamian. I'm going to present the extension to PSAP to support resource sharing based path computation. In this draft, we aimed at supporting the resource sharing during the path computation procedure, and we extended the PSAP to support specifying different resource sharing strategy. We also support the resource sharing scenario between different RSPs with different endpoints to make it flexible. And in the use case section, we actually include the single PCE use case and multiple PCE use case for interlayer path computation. And we also consider the resource sharing with different bandwidth or end nodes, which is quite a special case during the path computation. On the protocol level, we extend the PSAP to include the resource sharing object in the path computation request message. Yeah, next. And this draft was presented in Toronto, and after that, there is a few updates. Firstly, we disclose more details in the use case. We introduced the re-optimization procedure for path computation, which is quite frequently happen in the network and may have a higher demand for the resource sharing with the existing RSPs. And we also, in a multiple PCE use case, we also specify the higher layer PCE with the lower layer PCE together with their limitation for mutual resource invisibility. And we also show some different computation results with different under different computation policies. This will be included in the next page. And for the object, actually we are changing this first line with the RSO flags instead of the previous RSO code. And we also allow the new RSP to share with multiple existing RSPs in the optional TLV section. Next, please. And in this page, we show a two-layer network example. We can just use this example to show how the policy goes and how the computation result is. So actually, in the network, there can be either one or two PCs according to the interlayer PCE structure. But in this example, we just show the computation result with the different policies. Assuming we have a red one from the number node 1 to node 3, and now we are going to compute RSP from node 1 to node 4. And if we want to have a policy that we want to share as much as possible with the existing RSP1, the computation result will be the blue one, which has a common section as a link A, B. But if the sharing policy is to share as little as possible, the PCE will compute as try the best effort to compute a disjoint path, which can be viewed as a free one. As a lower layer, there is no overlap for the resource utility. And we also want to emphasize here in the RSO we extend the object only carry the two information. The first one is the RFP to share resource, and the second information is the resource sharing policy. The other information, including the bandwidth, the source, and the destination, are already contained in the other object in the PC request message. So yeah, we have received a few comments from both the mailing list and some offline, and we think we have addressed and make the solution clear. So we are here request for the working group to adopt this draft. Thank you.
So you may think that I woke up in a bad mood, but not at all. I'm just having a quick question. You know, you've got a few bits to say less, less sharing, try to do the most, but we worked on it when I was a young kid, so it was a long time ago, as you can figure out. But the question was, when you try, for example, to tie together two LSP, and you try to, basically have the max degree of sharing and all kind of stuff. But do you think really that, one bit that says try to share as much as you can or whatever is going to be sufficient?
Yeah, actually, I think there are three different potential computation results. First is the share as much as possible. The other is try to avoid the sharing, but it still replies an answer if there is no available resource totally destroyed.
Right, but it's a fairly complex, usually, back and forth between the PCC and the PC, because when you say try to share as much as you can or don't share, whatever, it depends on what you're trying to do. If this is N/M protection or these sort of things, sometimes, the objective function is a bit more complex than just one bit. That's all I'm trying to say.
Well, actually, currently the allocation of the bits may result in multiple solutions, but if there is some special requirement in the request, if there is not, it can be a random selection.
Right. So spot on. That's exactly my point. So let me give you an example. If you're trying to make them fully diverse, it may result actually in a big delta between the cost of the LSPs, obviously, because you're trying to make them fully diverse. It could be link, could be node, it could be SRG diverse, it could be LDG diverse, in which case you may have, two LSPs, fully diverse indeed, but with different delays, resulting if you do some load balancing, for example, in Jira. Yeah. You see what I mean? So I'm just trying to say that this notion of sharing is sometimes may require to have some more sophisticated objective function when you send a request to the PC than just saying, okay, try to do your best with just one bit. You see my point, or?
Yeah, I think this brings some complexity in the.
Let's hear the voice of a GMPS expert.
The policy.
Funny, I was going to talk about MPLS. Hi, Lou Berger. Just to expand on what JP is talking about, consider the case of what Creedy talked about in MPLS of the ECMP LSPs.
Right, exactly.
And you have some bandwidth. You do have bandwidth in your request. So one of the things you might want to do with this, and I was trying to figure out if this was your intent or not. There wasn't enough in the document. Is to support ECMP, where there's areas where you might have some sharing, there's areas where you may not. The whole point of what Creedy was doing is to allow, for instance, protection sharing in the case where there's a failure, and that's a specific form of sharing that he wants to extend or introduce with that extension.
Okay, I think the failure may result in different policies. And
so he wants sharing in the case of failure, but in the normal case to have full diversity, right? So you can get load sharing. So it's just it goes to JP's point that there's different types of sharing out there.
That's right.
From Jabber, Cyril. How is PCC reporting that the two LSPs are already sharing resources and by how much? Should I repeat? How is PCC reporting that the two LSPs are already sharing resources?
I think that there should be some clarification for the resource sharing. They must share the same slice of bandwidth rather than only run on the same link. So two existing LSP sharing the same resource, I believe it refers to the use the resource on the same link rather than the same slice of bandwidth.
Okay, thank you. I think we're gonna stop there. It seems that there is some more work to do before moving forward, so you have homework.
Okay, thanks for calling.
Please use the list to share your new material that you put in the draft and try to gather support and comment using the list, not necessarily for face-to-face meeting. Okay, thank you. We're a bit late, but we have some time anyway. We're moving to the second part of our session, which was related to our last milestone, which is recharter or close. We propose to start the session about considering new area of application of PC by a presentation from Pascal Teber about 6-ish on deterministic Ethernet or networking at large.
Yeah, I just wanted to say a few words about that because I think this is something very important for us as a working group. And Julien said at the beginning of the session that it could be, something to really consider in terms of, next step of a working group if we have more work to do or, basically we're done or not. And I just wanted to say it's too bad because Adrian left, but I'm going to look at Deborah, our AD. I know he's there. Okay, so I'm going to look at both of them. But we had that discussion about the role of the PC, for example, in deterministic, in 6-ish, for example, for quite some time. You remember, Adrian? I think that was about 2 years ago. And yeah, it may play a fairly big role. So pay attention because you see Pascal is an interesting guy. He's got a lot of stuff to tell us about. No pressure.
Thanks, JP. Can you hear me okay? Yes? Okay, so there is an effort which has started at the IETF in the form of BOF and external meetings. That's called deterministic networking. It actually is a generalization of work which has been done at the IETF, started for pro audio video and then generalizing to other applications like industrial and smart grid automation. And this prime of determinism is now expanding to layer 3 and other networks. So that's basically what I'll be talking to you about today. And by the way, there is a draft which is mentioned at the bottom of this slide, which is DetNet, or deterministic networking architecture. So that's a draft that illustrates how we would see handling this DetNet prime that I'm going to talk about. And the PC is mentioned many times in this draft. So if you could look at it, that would be of interest. Next slide, please. So first question is what IEEE calls time-sensitive networking, and at the IETF we have started to call DetNet or deterministic networking. Basically, the goal behind DetNet is to increase dramatically the delivery ratio of packets, reduce congestion loss. That's a critical need. In particular for audio video, if you are burning a Blu-ray across an Ethernet fabric, each packet that you lose is a scratch on the master, which means that every Blu-ray will have a prime on that particular spot. So we are talking about eliminating most of the reasons that you can get to lose packets. But to get there, you basically go beyond what we are used to call QoS into a domain where we know exactly which resources are being deployed in the network, and we can spot which buffer and which box will be used to transfer which packet at which point of time. And in very short, what I'll be explaining today is that the only way to provide this sort of capability is to program them from from a PCE. So let's see how that works. I have two analogies to explain how deterministic networks work. The first analogy that I have is the train. So one important goal for your train company is that there's only one train on the track, so as to avoid collision. Collision loss on trains is something you want to avoid. And the way to do that is actually to make sure that you know exactly when the train will reach the station, and if the way is needed for another train, then you need to move this train to queue it somewhere. And you need to have as many garage trails to all those trains as you have trains. If you don't have enough buffers, you have garage lanes for your trains, then there's going to be a collision. And so you store this train for a number of minutes in your station, and at scheduled time, the train will have the railway open for it, reserved for it, and then it's going to fly. And now if you figure all the train system in your country, all those trains being queued for some time in the station and leaving the station at the exact time at which they are scheduled, well, you have a deterministic network. That's exactly what it is. You have scheduled everything, you knew exactly how many resources were in the network, you have completely avoided congestion. And congestion loss is the major reason why you have drops in a switch network, in a Ethernet switch network. In radios, we have even more constrained reasons, and I'll talk about that. So collision avoidance is basically problem one. Next slide, please. The second illustration of what deterministic networking is the bus system. Now say you want to go from point A to point B using a bus, and you know that you have a bus every 15 minutes. So basically, and you get to the station at any time, and you'll wait up to 15 minutes at the station. But you know that within those 15 minutes, there's going to be a bus. And you know that this bus will take you in 30 minutes to your destination, which really means that in the 45 next minutes, you'll get to the destination anyway. Well, maybe not in France. But
and by the way, if I'm not mistaken, your brother is actually a pilot of this Airbus, right? Your brother, Pascal? Your brother.
Oh, yeah. Yeah, okay. That's
you have a brother.
That's true. My brother flies 380s. The 380 is built like that. Every packet that flies in the 380 is in a bus, which means that if the pilot moves his joystick, that's going to be within not 15 minutes but a few milliseconds, a train, a path through the network that has been reserved and placed over and over and over very rapidly, so that these commands are guaranteed to reach the destination, that they are guaranteed, just like if there was all green lights all across the city, that the packet is guaranteed to go through. The whole Airbus system has been pre-computed before the Airbus even flies. And your Airbus will run this program over and over and over. So what kind of application actually can need such stringent characteristics? One is industrial. This thing I mentioned with my bus is the way control loops work in industrial. So you get process control, kind of slow control loops to monitor the temperature of the ketchup and heat it up if it's too cold. And then you get factory automation, which is much faster. You can get hundreds to thousands of those loops per second. And the loops have to be very precisely timed. They arrive bang, 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 very precisely. And if you get some jitter there, then the adjustment that you make based on this particular exchange will be wrong. And maybe the process will derail. So the very precise time is an important characteristic for factory automation. Another use case, which is actually a very large use case, is Pro Audio. Pro Audio is not just the studio where the music is being produced. It's also churches, it's also Disney World. Right? The type of network that you deploy to actually automate the Harry Potter show at Universal Studio is all based on Pro Audio type of activity. It's all deterministic. Otherwise, people may have accidents on them. And then there are, we have actually a very good draft for the smart grid application. It's impressive the types of links that they have in smart grid, where they actually require very precise and very guaranteed delivery of packets. Next slide, please. So when we look at being able to be very deterministic on how we deliver the packets and when we deliver the packets, We are not virtualizing over virtual. What it's really about is which boxes I have, which links I have, regardless of whether the box is layer 2 or layer 3, by the way. And how many buffers do I have on that box? How precisely can I sync those boxes to make sure that there is the time that the packet is being sent, at the same time the next hop expects that packet. So they can actually figure that it is the packet we're talking about. Now, if we were to install deterministic network in a very simple, profane way, we would figure, okay, it's just a path across a number of devices, and I know I've got enough buffers, I know at which time I'm going to send it, that's basically my train. And I could probably envision to do that in a distributed fashion. But, next slide please. Deterministic networking is not just about scheduling everything precisely. It's also about reaching levels of delivery ratios that are way beyond what we do today on the internet. And to get there, we've got not only this tight scheduling and reservation of precise time where the link is ours, we also have additional mechanisms. And one of those additional mechanisms is the capability to actually send the frame twice, not only over 2 parallel paths, but also with the capability to resynchronize 2 copies of the packet and make one. So that's what we call frame elimination and replication. You've got points where you replicate the frames, and you've got points where you eliminate them. And because you're precisely timed, then you can actually have enough buffers to wait for the 2 copies, and then later you send 1 or 2 if you're replicating them. So the type of network that we are drawing is actually like this. And you need to know not only through which box you're going, but also which buffers you're locking, how long, and how many copies you will receive when, how many copies you will send when. That's the sort of need that you get for deterministic networking. Next, please. So to actually get there, I'm not aware of any person that has any company that has tried to do that in a distributed fashion. It's just too complex. But there are a number of places of standards which actually do that in a centralized fashion. For instance, I was talking about industrial, and my group 60 is about industrial over wireless. Well, there are standards, let's say semi-proprietary or particular standards, which already implement deterministic networking over wireless sensor network. One is ISA 1.3.11a, and we've got here the chair of the group for that. And another is wireless HART, and they both schedule completely the network from the perspective of a controller. And as we think about this, we say, hey, this controller, it's a PC, right? Next slide, please. Now we've been looking at how we could emulate at 6-ish the kind of process which is already happening at wireless HART and ISA 100, and then we figured that this problem is not limited to our wireless sensor networks. It's general to all sorts of IP links. And we figured, oh, but then the work that we wanted to do in 6-ish is actually much more general, and there should be an entity, maybe a new working group, which would care for deterministic networking in general. And 6-ish would be one user, actually, for our wireless sensor networks. And then there would be other users. So we started to figure, okay, how does that play in the IETF? What do we have in the IETF? And so we started drawing this kind of picture. And you see, we basically foresee a model which at the end is really pretty much the SDN model with a service interface which is sometimes called northbound. We are not too much interested in that. And then the control interface, the southbound interface between the controller and our 6-ish network or deterministic network. And for that, you realize there are a number of things which needs to be defined and which are not fully defined today at the IETF. To be able to express my buffers, my queues, my timers, the fact that I replicate or eliminate the packet. All this work has to be done so as to be able to express those needs, then compute in the PC what needs to be done, and then push back the results in my devices, whether they are 6-ish or manageable. I would add to that the push for going layer 3 is coming throughout the industry. So we got it through IEEE because the people started realizing that they need more than just one Ethernet fabric. Then we got it from smart grid, where they use all sorts of links. It's not only Ethernet. They've got microwave. So they get microwaves, they get all sorts of networks. We need to generalize that, and there is a need to operate at the IP layer to actually switch from one type of network to the next. Next slide, please. And so we wonder, between, you see the previous slide and this one, how our 6-dish network could be provisioned from this entity that for the time being we call the controller. And there are really two ways. One way is the TE fashion, so we inject the path at one hand and we place the reservations through. And the other possibility would be that the controller talks directly to the devices, which I understand is not exactly your models. Both model of
well, we have it with a stateful PC. You know, you can it could be initiated by the PC itself.
To every device one by one. Because imagine how this thing works. You get the PC obviously, which computes all the paths. And then what you want to do, because you're on a wireless sensor network, is push the schedule of every device in as few messages as you can. So what you want to do is make the image of what every device sees. And what the device sees is, oh, if I get something on this channel at that time, I'm going to send it on that channel at that time. That's how we do GMPLS. I receive at that time this channel, I send the same thing, whatever it is, at this other channel, this other time. We're really GMPLS. Okay? So we could figure tons of flows going through a device by just saying this goes there, this goes there, this goes there. And push that in one time to the device using direct flow between the PC and the device. But then if we have an update, if we have a new flow, you don't want to have to send messages through the fabric to every single device. Because that costs a lot. Going down and back up the WSN can be very costly. You'd rather send one thing at the ingress of the new path and program it through. So we can have a need for an hybrid model where we could do both. Basically install the initial computation like this, like a shower, and then update more in TE fashion. And now if we expand the view of this controller that I discussed, for us it's an obvious that the computation, and actually the maintenance of our network is done by a PC. We actually see three main entities. One is basically how you configure stuff, and that can depend on you're using OpenFlow, you're using whatever you're using, PSAP, obviously. And basically that gets you what you would get by doing CLI. I'm adding a path, I'm removing a path, I'm starting it, I'm stopping it. That's the command and configuration thing. On the right of my picture, I've got the runtime. Whatever feedback I get from my network, do I get the throughput I want? So do I need to increase my bandwidth because there are too many retries on my wireless? And so I need more time slots. So all this is the runtime, which will actually trigger the maintenance in the PC. So we see this, basically this chain of events. I'm getting something from my network which tells me I have put in place too many time slots or not enough time slots, which is bad anyway. Too many time slots, okay, I have more bandwidth, but I'm waking my device more than I need, I'm spending battery. Not enough time slots for my retries, well, too bad, the conditions went down. I need to increase the number of time slots to do my retries. Okay, so this adjustment comes to a measurement and management piece that needs to be pushed to the PC. So the sort of requirement that we have must be expressed in some fashion for the PC to redo a computation, and then the PC must express in some sort of fashion, abstract fashion, so that the command gets executed, whatever the environment is. And as we go, we have already defined the interface to our 6-dish devices in the case of 6-dish. We are using COAP, which means that whatever is the language that should appear on the left, we have to have a COAP version of this. Or it can be PSAP to a point, but then there must be a mapper which will be able to translate that into COAP forms. So that's kind of the challenge that we're facing.
And I was checking, Pascal, this is actually in the RFC 4655, section 5.3, allowing actually, each PC to provision intermediate node actually.
Yeah. Okay, I was not clear on that. So
yeah, no. Yeah.
So my message here is we probably need both models. The section that JP just mentioned is how we install the network with its expected configuration, and along the path may be needed for just installing a new path without going to all the devices, which could be costly. But it's a secondary need. The first need is really the shell. Next slide, please. So that's basically a summary of what we do at 6-dish. So 6-dish is based on the classical 802.15.4 MAC, but we have this layer which does time synchronization and allows us to cut the bandwidth in a matrix which is based on x-axis, that would be all the channels. We have 16 channels. And on the y-axis, we'll make time slots. And with that, it's pretty much like LTE. With that, we'll be able to say this particular cell in this matrix is reserved for the communication between A and B, and so we will avoid collisions between another packet which goes from C and D. Right? So to get there, we need a very precise time synchronization. On our very low power sensors, we are able to get to the tens of microseconds. On Ethernet, we go one order of magnitude less than that. We are in the order of microseconds and less, because we do things much faster. With this, we can reserve resources so as to make sure that the transmissions that we want to make won't get collisions. On radio, you always have all sorts of collisions because your own packet will collide with itself. So we have got a need to retry, we've got a need to replicate and eliminate, etc. With this, why do we do this deterministic thing? Because we reach extraordinarily low packet loss. Orders of magnitude better than if you do 15.4 without the deterministic. So on 6-dish, on existing networks like ISA 100.11a, the sort of delivery ratio that we get over multi-hop is in the order of 10 minus 4, 10 minus 5, which is, on those radios, extraordinary, right? A transmission is normally like 60% to 80% delivery. And not only do we get this ratio, which is what we really want after, but we also guarantee the latency because we know exactly which time slots are going to be used for this packet, or for all the possible ways for the packet to go from A and B. And with that, we actually guarantee the exact latency, how much time the packet will spend in the packet, and we can achieve almost zero jitter. In the particular case of 6-dish as opposed to DetNet in general, we also have an additional benefit, which is that since we schedule the transmission exactly, the receiver and the sender will wake up at the exact same time, do the transmission reception, and go back to sleep. The devices sleep 90 plus, 99 plus sometimes % of their time. That's how they save their battery, and that's how they can stay alive for 10 years on 2 AAA battery, because they sleep all the time. The sleep is very, very low in microcoulomb. So being able to schedule tightly the transmission and the reception allows to minimize the wake-up time. So that's an additional benefit of being deterministic for 6-dish. Last but not least, I must insist on this point. A lot of people tell us, oh, you're doing reservation. If you're doing reservation, you're wasting resources. It's like my frame-relay network. No. It's very critical, whether it's Ethernet or 6-dish, that if a certain resource is not being used by deterministic flows because at that time there was no packet, then we are able to actually use that resource for normal traffic. And if we schedule everything, we know what is scheduled, so we know the places which are empty, we know the gaps, we know the quote-unquote white space that we have between reservation. We are completely able to use that space for normal traffic, normal process. So the capability to use the same network for deterministic and non-deterministic traffic is actually critical. And that's basically my
Lou Berger. Can you go back one slide? Very interesting presentation. I was a little confused about whether or not you think the applicability relates to DetNet in general or 6-dish specifically, or if they're the same thing or different things, or how are the different pieces related, and what are you asking here?
This slide would be general to anything, but I needed to give numbers, and so the numbers are precisely for 6-dish. If you are Ethernet, you get one order of magnitude here, you get 10 minus 10 here. Okay, so the only thing which is specific to 6-dish, apart from the values I'm giving, is this battery life thing. Right?
So you think the work to be done is generic to DetNet and it's applicable to 6-dish?
Right.
Okay.
That's very important. That's why I called the presentation .NET, but my conclusion was 6-dish.
Yeah, but then you have this key takeaways on 6-dish, so that's the last slide. So.
Okay, so very good that you pointed out. I thank you, Luke.
I was just trying to understand, actually.
The prime is the .NET prime. We don't have a .NET working group at the IETF, so I can't push requirements from .NET to this group. But 6-dish has the exact same requirements as .NET. It's just a matter of scale. And basically, different networks will have different resources they manipulate. But Ethernet will be pure time. 6-dish will be time slots, which are length of time and a frequency. So the resource that you actually reserve and how many resources you have will depend on the type of network. But the generic need that I expressed, know your resource, schedule them, do frame replication and elimination, all this is .NET general.
Okay. I think you second question, I think you very accurately related your problem back to work that's been done in CCamp, and now maybe it's CCamp T's, I don't know, it doesn't really matter, but it was done in CCamp. And we've done a lot of the things that you're talking about, including the protection function in the context of CCamp, and there's even some Ethernet related work that's been done. So I think that was very good, but then when you continued on, you really focused on a controller-based approach as opposed to a GMPLS-based approach, as you mentioned. Was there a reason for that? Have you considered a control plane-based approach, or you believe that it is a requirement to do centralized, or do you want to do both?
Well, for the distribution of the path once it's computed, I mentioned that we need the two. For the computation of this complex thing, we decided to start simple, doing what the industry does, which is centralize the computation in the PC.
Okay, I misread your slide. When you had the slide with a centralized, I read that as...
This one and
this
one.
Either one. I can't.
Yes, there's two.
Either of these, I didn't really read the controller as a PCE. I read it as an SDN controller.
Well,
which is also okay. I mean, if that's the model you want to go, I'm not saying don't. I'm just trying to understand.
I expanded this, saying this is a controller of whatever you want it, but if you look inside it, the piece that will compute my path is a PC.
Okay, so, I mean, I think allowing both is actually the right answer myself.
Yeah. Or the answer is the PC is an element of a controller even if it does not do reset.
Thank you.
Hi, Igor Burskin, Ottawa. I think it's a very interesting presentation. So I have a question. Can I define this deterministic network as kind of time division multiplexing simulation or packet switch network with precise time synchronization? Is it possible to define this way?
6-dish is pretty much this way because we do time slots which are we do TDM, right?
Yeah.
With this thing that we run it over and over and over, so we make a sequence of maybe hundreds of cells of TDM slots, but we also have this x-axis where we have channels, right? We rotate the channels as well.
Right.
If you look at Ethernet, we don't use a TDM abstraction because that would be too small time sequence. So what we do is precise time. We say, oh, at this time it's this packet, then we do what you do, and then at this other time, so you don't have too many resources to manage. We manage exact times, as opposed to say we manage a matrix of tens of thousands of TDM slots.
You need that many? You need that many. So basically, if
we don't need so many flows, so that's why managing the precise time of each flow is less costly, so just associating timers to flows, as opposed to dividing the bandwidth in very small time slots. So we don't use time slots,
But you can apply, for example, the same hierarchy as Audio has. You know, you have like a bigger time slots, and within that you have like a smaller time slots and so forth.
Yes, that has been done in some Wi-Fi implementations, doing money and stuff. So this exists. But I don't think IEEE is using that.
Yeah, so basically, if we can model it this way, that from control plane point of view, from PC or SDN point of view, it could look like TDM, you know, kind of services.
Ultimately, it will, yes.
Yeah.
Maybe that will be devil in the details, but ultimately yes. But you need to account not only for the times, but you need to account for the buffers, make sure that you know how many buffers I remember my trains, right?
Right.
How many railways you can store different trains
right.
while one is going through. So you need to know all those exact details.
Yeah. So you need in any TDM, right, kind of networks, because basically it's a hardware imposed kind of things, and you have to do it in a way in software, all those kind of things, right?
If you really want to have a tight integration of time and sending, well, it depends on what your requirement is, but for the industrial process control and motion detection, they have to go hardware down really to they schedule the buffers and the timers and everything. It's all done in the hardware. Software would be too slow or too imprecise.
So I have a second question. So basically you also mentioned that if these time slots are not used, it could be used for other services, right?
Yes.
So I assume,
must insist on that, yes.
So I assume if you started to use these time slots and then basically the gold kind of quality service, this deterministic network LSP come along, you can preempt these things, right? So you just throw away.
You must be able to recognize if you reuse a certain resource, which could have been used in GMPLS fashion, so blind, I take this, put there. Oh, actually I reuse my time slot for an IP packet which just has one hop over the same cell. I need to be able to extract it from the flow and recognize it's not a GMPLS. So we have that in 6-stitch, yes, it's described in our architecture.
Again, very interesting, thank you.
Daniele Ceccarelli, thanks for the presentation, very interesting. While you were going through the slides, I was saying, oh, this is PC, oh, this is CCamp, oh, this is this.
And we need your
now
help
I would
to
like to understand what you're proposing. I mean, are you proposing to use the PCEP to do those provisioning, to do that provisioning, those configuration?
Actually, I'm not proposing anything. I'm asking you to tell me what to do.
Okay, that's great. That's great.
Right? We find that this seems to be in CCamp space or in T space. So we want to come to you with requirements saying, oh, you need I need to be able to pass you how many buffers I have. I need to pass you what my timers are, how precise I can synchronize my network so that you can feed that into your thinking. So probably there's a change in some data model somewhere.
Right.
And so I need to push to you my requirements about this data model so that you can include it in your exchanges. And on the way down, same thing. Maybe it's PSET, maybe something else. Ultimately for us it's co-op. We have to translate it if it's not co-op straight. But we know what we want. So we have a precise data model of what you need to publish into our devices. Question is, you don't know how to do that because you don't even know those elements in our data model. So we need to push that to you so you can compute it for us.
So maybe Pascal, we didn't do a good job explaining what we were trying to do actually. So just to explain a little bit. So in 6-stitch, what Pascal kindly enough, agreed actually to explain to the group is actually that when you look at that architecture, is actually they are actually using a PC, whatever we want to call it. And that does fit as well with the PC architecture. Now, as you said, maybe PCEP is way too heavy, especially for 6-stitch, and you need to have a different protocol. But the idea is more to see in the room if you guys think that that could be something interesting for this working group to take on and collaborate with 6-stitch. And of course, I look at the AD just to maybe chime in if they want to at some point. But this is more, the two groups trying to see if there's some synergy, interesting synergy.
My comment is that I think there is work for PCE, CCamp, and TIS.
Right, okay.
Which was our assumption. And our problem is to probably talk to you so that we can get this work done. That's what we are about.
Okay, thanks.
And as T-share, I'll duck, and I'll say, I think you can start in PCE and CCamp and work there for a while. And if you come back later and say, yeah, there's also something for T's.
Thank you, Lou.
Dhruv from Huawei, just a clarification question. Why are we saying that COPS and configuration on the node, that's the ultimate goal, and not just using the PCEP protocol all the way directly to the device? Why COPS? Can you explain that to us?
It's not COPS, it's co-op.
Co-op, okay.
So co-op is form of RESTful interface, like HTTP if you like, which is defined for low power lossy networks, which is defined for very constrained networks. So it's based on UDP, it's very, very constrained, concise in how it expresses things. So 6-dish has defined first an abstract data model, YANG, to express all the resources that you need to program in our devices to obtain this. And then we also have defined a way to go through our network to push that information. And as it goes, we cannot use TCP, we cannot use large messages because our frames have 127 octets. So we have to use something very, very constrained. The exchanges can be very slow. Your TCP won't, on multi-hop it will be an issue. One hop can be several seconds. So there are all sorts of reasons why we want to use a very constrained way to go to our devices and if possibly over UDP. So we have defined this interface which will fly over our wireless sensor network between some box which is there, which could be the controller itself or else there will need to be a mapper. But you need to express our data model some way, and then we figure how it goes to our device. But first we need to explain you what our data model is.
Just some clarification questions. So first one is, are you considering, or in this scenario, that you will have a large number of flows very long-lived? For example, one of the flows can be a sensor emitting or transmitting something periodically, and then that for you would be a flow.
Yeah.
So you imagine you will have, this will be very long-lived. Let's say that it's not something to be short, so it's something that we can say...
It's like 20 years, 40 years.
So it's something really long-lived and also a big number of flows, then we're assuming in this scenario. Or
do you have numbers? How many flows in one ASA 100 network?
An order of magnitude, or?
Order of magnitude is 10 to 100 devices in one wireless mesh. And maybe you can help there.
Yeah.
Go ahead.
Yeah, Thomas Otena. Yeah, that's correct. So 10 to 100 nodes in a wireless mesh. Nodes live for 10 years or more. Every node reports sensor data to some system outside of the network. And some of the nodes are actuators, and so you have sometimes some automation that comes back in. In the future, we're seeing cases where modes talk to modes, so you have kind of wireless control loops or similar things like this. So that should certainly not be excluded from the flows of data within those networks.
So we need to design for that. We need to design for the case where you get multiple small wireless sensor network which sees one another. Today they have one controller each. We may virtualize that into bigger boxes which may control more devices, establish path over multiple of those small subnets, if you like. And you might also want to, if you scale, because you can scale a factory to tens of thousands of the sensors, maybe you have the need of multiple PC. The sort of thing also we need to understand from you is, how does that match, for instance, the concept of stateful PC? It looks to us that seems to match this concept. Is it a real concept for us? We are coming with questions and requirements here.
Okay, and a last clarification question. Will we assume that there is a data plane that is taking care of all the synchronization issues, and that you say that the timing here needs to be very precise? So if you have one NIC that is sent at second X, we assume that you already take care of it, that there is a data plane that has the specifications are following it. So in the path computation, for example, we do not need to take care of any...
we need to tell you how precisely scheduled we are, because that's basically how many scheduled packets you can give us per second, right? Because if our jitter is like this, then you can give us that many packets. If our jitter is like this, then you can give us that many packets. We need to know, but the network, for instance, the 6-dish network, the schedule is at the core of how it operates. It's behind, it's underneath, it's the base of it. So nothing works if you don't schedule it. Ethernet is different. You run 1588 over your Ethernet lanes, so it's scheduled to precisely time them, and you go down to microsecond. But yes, we have to do it. That's the base of it. Everything is scheduled.
Okay, and then are you expecting reschedules? For example, I was thinking in the scheduling of flights where typically you have delays and then you have to reschedule everything, and you had a very difficult situation, fitting all the planes around, and then one got up late, and then you have to reschedule everything. So you are also expecting this kind of situation where you have to reschedule?
Thomas Watene, absolutely. This is a wireless network, so links come and go all the time. So you have to be dynamic. You have to have the mechanisms to be dynamic.
So it's a matter of use case. Now, in an Airbus client, no, not usually.
Just before leaving the floor to Sian, people before leaving the room, make sure you have signed the blue sheets. We need to know how many people we are to make sure we have the correct dimensioning next time. I don't know where they are, but try to find them before leaving, please. Thanks. Sian?
Yeah, Xian from Huawei. I just want to share my thoughts on this. I think it fits in the PC working group part of this. But you also mentioned about GMPS. I think if I understand correctly, the 6-dish or the DNet, it's how to say, the main application is for sensor narrow, right? So the power will be a constraint. If you're running a control plane, that's going to take more power from the sensor devices. So I don't know whether that's have you ever considered that?
Okay, so in 6-dish we run both this model and
distributed and centralized, right?
And Ripple. And with Ripple is distributed routing. So we have both actually. It depends on the application. But if we want to enable this complex type of operation, then we need a centralized computation. Now it's pushed once and it can live for 10 years. So the cost of pushing it is ridiculous compared to the cost of running it. And now if it's just stable like this, then there is no over and over routing thing happening in the network. So this is actually very efficient. That's how we run controllers in the industry.
It's a great way to conclude.
Hi, it's Adrian. It's my last chance to tell you what to do. So I will structure this more as some advice. You had a draft on the agenda you didn't get round to. It was in the bottom bit, if there's time, about PCE as an SDN controller. And this is, at least part of this is PCE as a piece of a centralized controller. And I think that the working group needs to take some time architecturally to look at where PCE fits into that type of architecture. I hesitate to suggest you limit yourself to the SDN buzzword, but look more generally at SDN, is it a control, PCE, is it a controller, is it part of a controller, and how does that fit? And then for this piece of work, I would strongly suggest that the right way to bridge the gap between, tell us what you want us to make, tell me how I could make it, is that you need to be gathered around a whiteboard. You need CCAMP people, TEAS people, PCE people, 6-dish people gathered around a whiteboard that smells like a physical interim.
Okay, yeah, I see what you mean. Thank you, Adrian. Makes sense. Thank you, Pascal. So I think that that does conclude our session, and well, see you next time. Thanks.
Protocol operates on particular time slots which are multicast because so you have time slots which are booked for the routing protocol. So you have the devices split. They have a schedule utilization. So you have slots which are new to you for data. You have other slots which are multicast for with arrays.
So which all right, okay, super, thank you.
We don't run those yet. We have Ripple, the only one. Routing protocol for low power loss.